Hi, I'm Cullen, and welcome back to Module 9 of Networking Fundamentals. Right now, we're going to talk about wide area networks. All right, let's go and take a quick look at our agenda. We're going to cover two different objectives today. We're going to talk about routers, how they work, and more specifically about static and dynamic routes, so the paths that data can take across the internet and across networks. And we're going to talk a little bit more in depth about wide area networks. The internet, of course, is the mother of all wide area networks. It's huge, but we'll focus on what wide area networks are, and then also talk about a few common connection types that you should be aware of, especially if you're heading off to take the networking fundamentals exam. So without further ado, static and dynamic routing. First off, a router, right? What is it? What does it do? It's just a central connecting device that uses TCP/IP routing protocols to forward packets. They use IP addresses like we discussed. It's a layer 3 protocol, right, IP. And routers connect local area networks to each other. And they allow communication between hosts on different networks. And so you see here with the bolded connections, let me bring up my pen real fast, that routers route data along pathways, right? Routes. And they enable communications between two different devices. And data can actually take a bunch of different routes. That being said, it can also take the same route every single time. But we'll feature that here in just a second. Routers have routing tables. And they use the information in these routing tables to make educated decisions about how we route from one host to another, right? So how we send data across a network or a wide area network, as we're about to learn in a little bit. Routing tables, they contain just a list of paths to various networks, and they can be configured manually or automatically. If they're configured manually, it's known as static routing, and automatically, it's known as dynamic routing. Okay. All right. To your right is an example of static routing. What's going to happen is every single time when you send data from your device here to this server over here, is going to follow the same exact route. Now, the server, if it sends data back to you, may not necessarily do that. It may be configured for dynamic routing and not static routing. So keep that in mind. A static route, clearly just a fixed path. I really want to emphasize that, right? It's definitely a very, very fixed path. So data is always going to travel down that fixed path. One thing that's really important to note about static routing is that if any links or any hops happen to go down, then what happens is you can't send data to that destination anymore. The route is just simply unavailable, and that means that it's not fault tolerant, which can definitely cause you some problems, okay? So let's go ahead and take a look at the slide for dynamic routing. Oh, I feel like everybody needs to watch that animation again. Hold on just a second. Wait for it. There it is. Dynamic routes. Routes change, right? Dynamic routing allows a router to detect when brand new routers are connected. And this means that the new pathways are available for sending packets. And so routes are then added to the routing table dynamically, right? So they're just automatically updated. That's what dynamic means, right? Automatic, just adjusts. This type of routing is fault tolerant because what happens is if you have a connection that goes down, maybe you have like 3 connections that go down, right? Guess what? I can still send my data down a pathway to the server. So dynamic routing, super helpful, always aware of the best place for us to send our data when we're moving from router to router. It ensures efficiency, fault tolerance, and just effectiveness of the internet as a whole. The dynamic configuration of a routing table isn't possible without protocols. And protocols, of course, are our favorite things because they make sure that the internet functions. There are a few different protocols that you need to be aware of for dynamic routing. You've got RIP, Routing Information Protocol, OSPF, which is Open Shortest Path First. It's a protocol that monitors a network for routers. And it'll adjust the routing table based on when the link state of a router goes on to off to on, and so on like that, right? So it always is aware of which devices are on in a network. Then you have IGRP, the Interior Gateway Routing Protocol. And you also have Border Gateway Protocol as well. Definitely do a little bit of research on each of these protocols. Know that there are things called distance vectors that you should be aware of. And what that is it's just a calculation. It's essentially a metric that's used to determine which route should be used to send packets, right? So some routes are better than others. Just like if you're trying to make sure that you get across the bridge during rush hour. Sometimes it's better not to take the bridge. You don't want to take the route that might be the most direct. Sometimes it's better to go around. And so just like us being dynamic in our cars and our vehicles, or even by walking or taking the bus, sometimes we reroute ourselves in order to make sure that we get there in time. So our data is no different, okay? Let's go ahead and go back to the slideshow. Just a real quick review on routing tables. In larger networks, storing information in routing tables requires a lot of memory. And so just more entries means more memory. And the number of entries stored will dictate how routers and routing protocols are used, or rather, which ones are used. And so there are a lot of different factors that will go into how we set up routing on our networks. Okay. All right, so let's talk about wide area networks and what they are. First off, the internet is a wide area network. Wide area networks, they just connect multiple local area networks over large geographical regions. And so what you would see here on this slide, if these were connected, is you might have routers that sit at the edge of each of these local area networks, right? And they may be connected in a mesh topology in order to make sure that each of these local area networks are able to communicate. And of course, those routers would all be connected to our switches, right? The internet, the largest WAN in the world. All right, and the internet in general, WANs, LANs, they use a technology called packet switching. And packet switching means that the data is broken into small segments, and then addressing information is added to each segment in order to make it a packet. And then from there, routers transmit packets across networks from one LAN to another, right? When packets arrive at their destination, they're simply reassembled by walking through the communications subnetwork, the OSI model, and they're reassembled into the wonderful, beautiful imagery and data that we see on our screens. Examples of packet switching protocols that you should definitely be aware of for this exam are X.25 and also frame relay. All right, so let's talk about the different kinds of connection technologies that are available in WANs, right? So how do we access the internet from our home or from our office? What kinds of technologies are available to us to connect to all that data out there? So first up is T-carriers. A T-carrier is just a telecommunications carrier. It's a cabling system that transfers data at high speeds. It's a dedicated line, right? So if you have a line leased from a T-carrier, you're going to have some pretty high transfer speeds. There are two common carrier systems. There's T1, which is also known as E1 in Europe and J1 in Japan, and then T3, which is known as E3 in Europe and then J3 in Japan, respectively. These are private lines between LANs, and sometimes you might find different offices using T-carrier systems. So, all right, next up is ISDN. ISDN is just a digital technology that's developed to offer faster communication speed than an analog telephone line. So telephone lines, of course, if you ever had a dial-up modem, they weren't very fast. It resulted in just painful download speeds. but it's just a ISDN is a communication standard enabling. It's a set of communication standards that enable simultaneous digital transmission of data, fax, voice, and video. And so another way of putting this is that it's a converged network because all those services are offered on the same line. And I may have not said it aloud, and you probably see it on your screen there, but ISDN stands for Integrated Services Digital Network. All right, next up is the Fiber Distributed Data Interface, or FDDI. It's a standard for transmitting data on fiber optic cables at a rate of around 100 megabits per second. The cool thing about FDDI is that it supports transmission beyond 50 miles, and it's also it's the original FDDI standard called for a physical double ring topology. I honestly wouldn't even know how to draw that specifically right now. So definitely go ahead and give that a quick Bing search. FDDI is primarily a protocol used on backbone networks. And something that I think is really interesting is backbone networks just in general, period. That's where all data is being sent across the internet at super high speeds, right? So the internet is a really, really complex system. It's got a very complex infrastructure, but the backbone is where things are being sent back and forth at its fastest, right? It's the reason why we can send a ping and get that back in just a millisecond, or why we can go ahead and send a DNS request across the globe and perhaps access a website in just nanoseconds. Like, it's absolutely insane how fast the internet can be and how fast networks are. Okay. All right, next one up, we'll go ahead and detail a new communication technology. The digital subscriber line, or DSL, is just a family of technologies that provides data transmission. It uses local telephone networks to do so, and so voice and data can be run over the same line. Just uses a higher frequency band to transmit data, so you've got 3 different varieties of DSL here. We have XDSL, we've got ADSL, and then SDSL. All right. Make sure that you're aware of all of those different varieties as you're studying for the exam. All right, broadband cable, this is where we use, it's broadband cable is just used for cable internet and cable television. This is probably what you have in your home, right? I have it in my home. It operates at a higher speed than DSL, and the rates can range from 384 kilobits per second to 20 megabits per second. So that's a pretty common network speed for a home internet. So this is something that you're probably using right now, and you may not even realize it until now, right? Because I just told you. Cool. Last technology that we're going to talk about is POTS, which is a plain old telephone system. So I don't even use the telephone system anymore. I have a cell phone, and so I use a cellular network. But the POTS system is what we use for regular phone lines. It's been around since the 1940s. It's now digital, but it used to be analog, and it also depended on something called circuit switched technology, where you had a dedicated line. And so if I picked up my phone to call somebody, and then somebody else in the house picked up another phone, then what that would mean is that that person holding the other phone in my house would hear everything that I was talking about with my friends or my family or maybe my girlfriend at the time. It was always really embarrassing. Anyway, that's it. That's all we got for this slideshow. Let's do a quick review of our agenda here. We talked about just routers, static and dynamic routing in general. We also touched on what wide area networks are, as well as some of the connection types that are featured in wide area networks that help us communicate. So that's all I've got for this mod. I'll see you in the next and last one. Thanks so much for joining me. Take care.